Mm. Hi everyone, this is Xinxin Li. Our paper is a 43 language multilingual punctuation prediction neural network model, which is completed by Edward Lin and me. I will introduce my paper from this part: the motivation, method, experimental results, and conclusion, and our conclusion. The background is SR results are usually lack of punctuation. Punctuation prediction is an independent component in the SR system. Punctuation is essential for user readability and downstream NLP tasks, like machine translation, language understanding, and so on. We want to support many languages punctuation with one model. In our assumption, utilize the shared cross-lingual information to promote the performance on low resource languages. This is our method. Firstly, we put the sentence multilingual multilingual BPE component to split the word, and then we get the BPE tokens. Our neural network is BPE token based. Mm, we put the BPE token through the embedding layer and the LSTM layer to predict the punctuation. We analyze the our multilingual BPE can support more than 100 languages. We analyze the overlap percent across three languages: Spanish, French, and Italian. The overlap percent is higher than 90%. We train the LSTM with shift. Suppose shift is 2. We append two special tokens paired at the end of text sequence and add two paired before the punctuation sequence. Then realign the text and punctuation, and then realign the text and punctuation sequence. LSTM with shift can look ahead some future tokens, which can reduce the gap between unidirectional LSTM and bidirectional LSTM. Our experiment, our training set contains 43 language news text. The data size is more than 500 million sentences. Our test set contains two parts: the in-domain test set and the out-of-domain test set. The in-domain is from the same data source as the training set, and the auto domain is the SR results text. We labeled 10 languages text with punctuation, which totally contains 29,000 sentences. The baseline model is the monolingual word-based model of 10 languages. The model is one layer LSTM with 1,024 nodes. The shift is 4. Our multilingual model has 133,000 BPE tokens. We tried 1, 2, and 4 layers LSTM with 1,024 nodes in each layer. The shift is 8, considering that a BPE token is a smaller unit compared to word. We use precision recall and F1 score to evaluate the performance. Punctuation includes the comma, period, and question mark. For period and question mark, we distinguish those appear in the middle or at the end of a sentence. Our first experiment is on 4 Romance languages. We train a model with 3 languages: French, Italian, and Spanish, and we take Portuguese as a low resource language. The table is the F1 score of the 3 languages. From the table, we can see that multilingual BPE model F1 score is close to the word-based model, and it is better than the monolingual BPE model. The graph is the trend of Portuguese F1 score with the data size. Baseline is the model. Baseline is the model trend from 0, and the adapter is fine-tuned from the multilingual model. We can obviously find that the F1 score improves along with the increase of data size, and the fine-tuned model is better than that trend from 0. The gap is around 2%. This is the punctuation result. This is the punctuation results on 43 language news test set, the Indo test set. The one layer, 2 layer, and 4 layer LSTM model. Precision recall and F1 score on all the punctuation increases with the deeper model. We obtain 4.1% absolute gain on overall F1 score from 1 layer to 4 layer model. This is the results on 10 languages SR text test set. We compared with the word-based model. All the 3 multilingual model perform better than the word-based model. The improvement is not obvious when stacking more layers compared to that on the Indo test set. We also calculate the confusion matrix of 4 layers model on SR test set. From the confusion matrix, we can find that we can find that 25% actual comma is predicted as now, and 43% middle period is predicted as comma. At the same time, 19% middle period is predicted as now. In my opinion, this is more harmful. This is more harmful as the period is usually powerful and deterministic. Our conclusion, multilingual model shows better performance compared with several monolingual models by sharing linguistic knowledge across languages. And the second, fine-tuning multilingual model also shows the expected benefit for low-resource languages. That's all. Thank you.